Okay, now we will understand the concept of keys, also called as super keys. Okay, we have a person, or rather we have an entity type called person, which has attributes like name, a PAN number. PAN number is a unique number which is assigned to every person in India who pays tax. Okay, cell phone number, we have an address, and we have a license number of this person. Okay, we are assuming that license number are unique across different states, which means I would rather say license numbers are unique only within a state, which means in Maharashtra I can have a person with license number 1253, and in Punjab also I can have a person with license number 1253. Okay, so I say a key or a super key is a set of attributes. It's a set of attributes that allows me to uniquely identify an entity. Okay, identify an entity. So let's see in this entity type, what do we have as keys? License number and address plus address plus name. Okay, is it a super key? Let's say we have a license number 1273, an address of XYZ Lane, Punjab, and a name of Shri Ram. Okay, does this set of information allows me to uniquely identify a person? I would say yes. 1273 and Punjab obviously uniquely identifies a person. Apart from this, we also have his name. So it is just not possible that there can be two Shri Rams in Punjab having the same license number. So I say license, address, and name is a super key. Okay, so what is a candidate key? Let's understand what is a candidate key. Okay, candidate key is a minimal super key. Minimal super key means you cannot delete an attribute from the super key and still uniquely identify an entity. Okay, super key minus some attribute is not equal to super key. Okay, if we have a super key, okay, it's a bit confusing. I'll take it in some other way. Candidate key is something, or rather candidate key is a super key from which you cannot subtract an attribute and still have a super key. Okay, so if this is a candidate key, then candidate key minus attribute is not equal to super key. And a super key minus attribute may be equal to super key. Let's see how. So we've said that license plus address plus name is a super key, okay? So let's see if we can delete some attribute from this and still be able to uniquely identify a person. Can I say license plus address is a super key? Yes. Because if we know the state and if we know the license number, we can actually identify a person. So this is a super key. Okay, can I still delete some attribute from this and get a super key? Would just the license number give me the information to identify a person? No, there can be two license numbers in two different states for the same person. Does just the address help me find a person? Obviously not. There can be 10 persons living under the same address, under the same roof. Okay, so I say license plus address is a candidate key, which means you cannot delete an attribute from this and still get a super key. It's not possible. It is a minimal super key. And what is a primary key then? Primary key, I define it as a candidate key which is selected by the database designer to identify different entities. Okay, we can have n number of candidate keys, but we only select one of them which serves as information regarding uniquely identifying a person or an entity. So in this case, this is a candidate key. Okay, PAN number, obviously I told you it is unique. In India it's gonna be unique. And this combination is also unique for a person. This is also a candidate key. But say if I'm the designer of this database and I say I'm going to have only PAN number as an identifying criteria, then I'm basically saying that PAN number is the primary key. So that is the concept of a primary key. Just understand, let's say this is the universe of super key, okay? Then this is the universe of candidate keys, and this is the universe of primary keys. Okay, super, sorry, this is super, and this is a candidate key. So I can say that every primary key is a candidate key. And every candidate key is a super key. Okay? And primary key is obviously also a super key, but it's not vice versa. A super key may not be a candidate key, and a candidate key may not be a primary key. Now, let's look at the concept of a weak entity set. Weak entity set. Okay? I define a weak entity set as an entity set in which there are no super keys. Entity set having no super keys. Let's see how that is possible. Let's assume we have a relationship between a boy and a girl. Say it's a dating relationship. Boy dates a girl. Okay? Now, while dating, this boy gives gifts to this girl so that the boy can please this girl. Okay, he can woo her rather. So this boy maintains a journal entry. He has a book in which he writes down the date and the gift. Okay, every boy who is participating in this dating relationship gives something to his girl, and that gift and date every boy writes it down in his journal. Okay, so let's try to model this journal. So it would be something like 12 December 95 flowers, 18 December 96 a pendant. Okay, again 12 December 98, or rather make it 95. Say a t-shirt. Okay, so we can have a possibility where Jimmy gives a flower or a bouquet of flowers on 12 December 95 to Janie, and Joe gives a t-shirt on 12 December 95 to Jill, right? And it is also possible that Ricky on 12 December 95 gives a bouquet of flowers to Joanna. Okay, So it is not possible for me to model these journal entries as I don't have a proper super key. These journal entries obviously only have two attributes. It has a date and it has a gift name. Okay. So as you can see, it is possible. Obviously just the gift name is not a primary key, or just the gift name is not a key at all, and the combination of the gift name and date is also not a key, because we have two members here from the same set having same values. Okay, so if I have to model this set, this entity type, I have to relate this journal entry to the boy. Okay. So, however, if you just realize here, if you include the name of the boy, then you are able to uniquely identify a journal entry. Although we were not able to distinguish between these two, but if we include the name, then we are able to distinguish it. The one was given by Jimmy and the other was given by Ricky. Okay, so we say a weak entity set is dependent on the strong entity set. Okay, strong entity set is the one which has a key. So and the strong entity set is called an identifying entity set. Okay, identifying entity set. So here this identifies these journal entries. Okay, it distinguishes between these journal entries. Let's suppose we have more entry. We have one more Jimmy, and the date is 13th January 96, and he gives, say, a Valentine Day card. Let's make it 14th February, and he gives a Valentine card to Janie. Okay, it is possible, right? Now let's just realize here that there are two Jimmys, as in there are two entries of Jimmys, but they have different journal entries. Okay, one is describing the date, rather it's describing that on 12th December 95 he gave flowers to Janie, and the other is describing that on 14th February 96 he has given a Valentine card to Janie. Okay, so between the same entity, the attribute that identifies a journal entry or that identifies an entity in the weak set is called a discriminator. So here, the combination of Valentine card and the date, and a combination of flowers and the date, can distinguish between these entries, right? Despite the fact that these both were given by Jimmy's, I can easily identify that these are two separate entries. So we say that the attribute in weak entity set that distinguishes between different entities participating in the same identifying entity, or rather participating with the same identifying entity. In this case, the identifying entity is Jimmy, is discriminator. Also known as partial key. Okay, discriminator or partial key. The combination of date and the gift is the discriminator in this relationship. A weak entity is said to have a relationship with the identifying entity, and this relationship is called identifying relationship. So what is our identifying relationship here? It is person writes a journal entry. Well, we describe a weak entity set in an ear diagram by double rectangle. Okay? And this identifying relationship is represented by a double diamond. So here we have this relationship. This is the identifying relationship. Okay. Just realize we have two attributes here. We have the date and the gift. And we do not have a super key in the journal entry entity type. Okay. Now we are going to look at the constraints on relationships. Okay. The first constraint is mapping cardinalities. It tells me how many entities in one set is related to a particular entity in another set. Okay, so we have person owns a pet, right? So mapping cardinalities is going to tell me how many persons own a particular pet, or is there a pet which is being owned by more than one person? That kind of information we get from mapping cardinalities. Say Joe has 3 pets, okay? The pets are Tommy, Cece, and Pichu. Okay? Joe has 3 pets. So it basically means that one entity in the person set is related to more than one entity in the pet set. Okay? But obviously we don't have a scenario where a pet is being owned by more than one person. Okay? We cannot have Bruno being owned by Jamie and Roy. Like, it's not possible. Not possible. So my mapping cardinality specifies a constraint that one entity in person is associated with more than one entity in pets. Okay? So there are 4 types of mapping cardinalities: 1-to-1, many-to-one, 1-to-many, and many-to-many. Okay, we've already taken a look at 1-to-many kind of relationship where we have one Joe owning many pets. Now let's look at 1-to-1 kind of a relationship. Person owns a license. So this is a 1-to-1 kind of relationship because every person is allowed to own only one license. Let's just assume that this is so, okay? So we only have one person owning one license. Okay? This is 1-to-1. These are also referred as 1-to-1, many-to-one, n-is-to-1, 1-to-many, 1-is-to-n, and many-to-many, m-is-to-n. Okay? So this is a 1-is-to-1 kind of relationship. Now look at many-to-one. We have set of watches, owned by person. Okay, so obviously many watches can be owned by one person. So this is an n:1 or many:1 kind of relationship. And finally we'll take a look at m:n or many-to-many relationship. Person owns company. A single person can own more than one company, right? There is no problem with that. Jamie can own Techsoft, can own Infosoft, and can own Brazil Dyes, right? There is no problem with that. And it is also possible that Brazil Dye is a partnership, and we have three owners with this. We have Joe, Sean, and Jamie, right? So at this end, one Brazil Dyes to many persons, and at this end, one Jamie to many companies. So we have an m:n or many to many kind of relationship here. Okay, so that was about mapping cardinalities. It tells me how many entities in one set is associated to a particular entity in another set, or it rather restricts the association, in the sense, if I say that this association is n:1, then I'm restricting the fact that a watch, or rather watch, can be owned by a single person. When I say it's n:1, I ensure that there cannot be two Rolex FAB9 model, I don't know if it's a model, but just for the sake of simplicity, being owned by Jamie and Sean. It's not possible. A single watch is always owned by a single person, because I'm enforcing that condition by my mapping cardinality, which says it is a n:1 relationship. Okay. Now the next constraint that we have is a participation constraint. Participation constraint. Okay. Let's revisit our pet, or rather person owns pet example. We have Jamie, we have Sean, we have Joe, we have Ricky, and we have Cece, we have Bruno, we have Pichu, and we have Tom. Okay. So here, Jamie owns Bruno. Jamie also owns Tom. And Sean owns Pichu. And Ricky owns Cece. Okay? So now I see that this is a person entity set, and this is the pet entity set. This is the pet, this is the person. Now I see in this owns relationship, there is a guy named Joe who does not own a pet, which means he does not participate in the relationship owns. Okay? However, there is no pet in this set which is not being owned by someone. Okay? So, I say that person owns pet. In this relationship, the person entity set participation is partial, which means not all persons own a pet. File. The pet entity set's participation in this relationship is total, which means all the pets participate in this relationship. We describe, or rather represent, total participation by double line. This means all the pets participate in owns relationship, while not all the persons participate in owns relationship. So these were the two constraints that we had in relationships.